Now dear student, we are going to discuss question number 1.8. In this question it is given to you 2 point charges QA, that is 3 microcoulomb, and QB minus 3 microcoulomb are placed at 20 centimeter apart in vacuum. This is given to you in a question. Clear? Now we have part number A. What is electric field at the midpoint O on the line AB and joining the two charges? Okay, fine. Second, we have to find if we put a negative test charge of magnitude 1.5 into 10 to the power minus 9 coulomb, or we can say 1.5 nanocoulomb, then what will be the force this is experienced by this test charge? Clear? So this is a question related to electric field. Clear? So we can say whenever we have a charge, and definitely at that time we can say that due to that charge we have an electric field. So when we place another charge in that electric field, it will experience a force. Clear? So in this question we have to find number 1, electric field at the midpoint, that is line joining two charges. Clear? Second, our objective here is to calculate force this is acting on a test charge. Clear? So now we are going to discuss solution, so concentrate on a screen. Listen carefully. In this question it is given to you, we have 2 point charges. So let's suppose I am taking here, let's suppose this is A, this is a point charge, and let's suppose here we have this is point charge B. Clear? And value of QA, this is given to you plus 3 microcoulomb, and value of QB, this is given to you minus 3 microcoulomb. Clear to you? It is located at 20 centimeter apart in vacuum. So we can see value of R, this is given to you 20 centimeter. Clear to everyone? Okay. Now what is electric field at midpoint O of the line joining AB between the two charges? Means let's suppose I am taking here a point, let's suppose this is point O, and this point O is a midpoint between A and B. Clear? Now how we will find here the net electric field? Clear? First we have to find net electric field at O. Clear? So first we find here direction. Actually electric field is a vector quantity, so we can say it will have number 1 magnitude, second one is direction. So first we find here direction logically, or you can also utilize here vector method. Clear? So I am finding here electric field direction first logically, then I will calculate here magnitude. Clear? So now concentrate on a screen. So now we can say electric field due to charge A, this is equal to, we can say because this is positive charge, so we can say electric field direction is always away from a charge. Clear? If we concentrate on a charge B, so definitely we can say electric field is acting in the direction of OB. Clear? Because this is negative charge, electric field direction at any point always towards the charge. Clear? So what is net electric field at point O? So this is given by, we can say this is EA plus EB. Clear to everyone? So now we can calculate here value of EA. How can we calculate? Now we know that EA due to point charge we can write like this, QA over this is we can say R by 2 whole square. Yes or no? So from here you can write like this, value of K we have 9, or directly you can first write like this, this is K, value of QA. Clear? So we can say this is QA, and we can say this is 10 centimeter, so we can say 10 minus 2 whole square. Yes or no? So this is value of EA. Same if we find value of EB, how can we write here? We can write like this, EB, this should be given by K QB divided by, this is 10 into 10 to the power minus 2 whole square. Clear to you? So now we are going to calculate value of electric field. So we can write like this, K value of EA, we can say this is equal to K divided by 10 into 10 to the power minus 2 whole square. Clear? And in the bracket we have QA plus QB. So this is QA plus QB. Clear to everyone? So now we can put here value 9 into 10 to the power 9 divided by, this is 10 to the power minus 1. So we can say this is 10 to the power minus 2 multiply QA plus QB. QA plus QB, QA is given to you, this is we can say 3 microcoulomb. Okay, important point, here you cannot write minus because we have already taken here direction logically. So we will put just magnitude here. Clear? So we can say here we have 3 plus 3, this is microcoulomb, so we can write like this minus 6. Yes or no? So from here we can say this is what 10 to the power minus 4. So 9 multiply 6. We have here this is 54. So this is 54 multiply 10 to the power 9 and this is 10 to the power minus 4. So we can say 10 to the power 5. Clear? What is unit of electric field? We can say this is Newton per Coulomb. Clear? So now we can write like this. Now we can say like this. Value of electric field we have at point O, this is given by 5.4 into 10 to the power 6 and this is Newton per Coulomb. Clear to everyone? So this is value of net electric field at point O. Clear? Now we are going to discuss part number B. In part number B, it is given if we put a negative test charge of magnitude this one at this point, what is force experienced by test charge? Clear? So now listen carefully. Yes. So if we talk about part B, now we are placing here a negative test charge. Clear? Negative test charge means what? We can say if we are placing here negative test charge, what is direction of force? Clear? Listen carefully. If I again draw here diagram, it will be better. Yes. Listen carefully. So let's suppose here we have a test charge, point charge. This is A and this is B. Clear? This is given to you in a question QA. This is equal to plus 3 microcoulomb and QB. This is equal to minus 3 microcoulomb. Yes. Now we are placing here a test charge and this is negative test charge. So we can say this is 1.5 into 10 to the power minus 9 coulomb. Clear? Because this is negative test charge, so first we will find here direction of a force. So we can say, we can write like this. Force this is exerted by A on O. Clear? This is in this direction because this is positive, this is negative, attractive force will act. Here we have negative charge and here we are having negative test charge. So it will repel and we will find here this direction FOB like this. Clear? Now if we calculate F net, we can write like this. F net, this is given by, we can say FOA plus, we can say, or we can write like this. F net equal to, we can say, test charge that we are placing at point O and electric field at O. Yes or no? So we can say test charge value is given to you 1.5 into 10 to the power minus 9. So we can write like this 3.2 into 10 to the power minus 9 multiply value of electric field at O. This is 5.4 into 10 to the power 6. Yes or no? This is given to you. Yes. So from here we can say, we can write like this. This is 10 to the power minus 3. Clear? And we can say this is what? 2.7. Clear? So from here we can write like this. This is what? 8.4, 8.1. 8.1. Clear? 8.1 into 10 to the power minus 3 Newton. Clear? So this is value of force, this is exerted on a test charge. Clear? So this is all about this question.